Hello, Simon.
Hey, Simon.
Welcome.
We're here at Weistechnik at our Hamburg site, and where we produce and plan and engineer the dry rooms for the big battery production projects. My name is Jullian. I'm Global Sales Director of Battery Production and Drive-In. I'm standing here with Till, Project Manager for the dry rooms. And in the next couple of hours, we're going to show you around our site here, going to show you our dry room, our R&D dry room that we have down there in the workshop, and show you what we're going to do with it. And also we're going to show you how we actually simulate and computer simulate our dry rooms on a VR goggle, so you can have actually a look how it looks like when there's a finished project in there.
All right, I'm looking forward.
Welcome to our R&D dry room. This is our test facility. And here everything is about ultra-low dew point application, which is, as you know, needed in the battery production industry due to safety reasons and quality reasons, and due to the fact that lithium is very sensitive with moisture. Always very, very dry air is needed in the battery production process. And yeah, this facility was built last year. We can consider it as brand new. We are very proud. And if you're interested, we can show you a little bit inside of the technology that is actually needed for creating such low dew points. So what we see here is the heart of every dry room application. It's the dehumidification system. And this unit here, which in the first step looks as a regular air conditioning system, where we are filtering air, we are cooling air, we are heating air, we are moving it with several fans that are inside. But the major difference is that we use with the process, so-called adsorption process, we are drying the air to a very, very low dew point. I will explain later what dew point actually is. And inside here, I will also open it now. We can show you how we do it actually. The secret or the technology behind it is a rotating wheel that we see here inside two different air streams. On the lower part, we have the process air, which is very, very dry. And on the upper part, we have the regenerated air. And by adding immense amount of heat into the process, the wheel is constantly regenerated. So it has silica gel on the surface, which you maybe know when you buy electronic equipment. There's always a small bag of silica gel. The silica gel is taking this moisture, and as it is a continuous process, the wheel is then regenerated again, as I said, by adding heat to the system. And this can be done having waste heat, hot water, electric heat in the worst case actually, or gas-powered heat. And by doing this in two different stages, we at Weistechnik, we are here convinced of the two-stage technologies. We have two different stages of adsorption wheels. And with this process, we are able to produce these low dew points. So following the air here, the air goes up there and then right into the dry room. And if you're interested, we can of course also check out our dry room and go inside. So before we go into the room, we have a small look here at our automation system. This is our own programmed software that we are using here, customized, but based on a certain standard for dry room application. Currently, we are at a dew point of minus 56 degrees. And just to shortly explain to you, what does it actually mean, dew point of minus 56? We are standing now here in a surrounding temperature of 20 degrees, maybe 20 to 30% relative humidity. So we can say here, right now, we have a dew point of plus 5 degrees, as an example. And this actually means any surface colder than 5 degrees, on any surface, you would see condensing water, which you may know from a nice cold and fresh beer bottle taking out of the fridge in summertime. This is a good example. So minus 56 degrees means now, in theory, in the dry room, you need a surface colder than minus 56 degrees to create also condensing water. And this gives a very good impression how dry the air actually is. And converting it in relative humidity, as I said, here we have 30% relative humidity. And minus 56 degrees dew point at 20 degrees air temperature is far below 1% relative humidity, 0 point something. And this is one reason because in the dry room industry, we always talk about dew point and not relative humidity. Yeah, so let's go inside, I would say. So what are we actually doing here in our test dry room, in our R&D facility here? The biggest challenge in dry room application in the battery industry is the reduction of energy consumption, obviously. Yeah? As I said earlier, the dry room takes about up to 40% of the energy that is needed to produce a battery cell. And of course, this we cannot accept and we will not accept. So this is one reason, or the major reason we built this facility here. And very interesting aspect, we are partnering with the Technical University here in Hamburg. And they have built a complete digital twin of the system, showing all the thermodynamic processes. So they can test and adjust certain parameters on their end, and we can then validate them here in realistic condition. And they see very, very promising results already, especially for the sorption wheel, which I explained to you. And then we will test this out and see what does it mean to the energy consumption.
Another point regarding the energy consumption is always heat pumps. I mean, everybody's talking about high temperature heat pumps nowadays, and we actually plan of integrating a heat pump into this because, as Till explained before, we need very high temperatures to regenerate our adsorption wheel, and that can be done by a heat pump, for example. So that will save a lot of energy in the whole battery production process. So that's one thing we're going to do in this room. Also, we want to validate all the components before they go on site, before they go on the construction site, and see whether they're actually working and how we can optimize them. So we actually have like a laboratory here to test everything beforehand. And actually, we've got a small model of a dry room in here, which I'll use to explain how a dry room works. So as we said before, we've got recirculation air, so we have to recircle the air from the dry room into the DHU again, and this can be seen here with our red ducting, so it's getting recircled and recircled the whole time. So every time it passes the DHU, we actually dehumidify the air again. And then to bring the very low dry air into the dry room, we actually use the textile hoses, which can be seen in our model, but can actually be seen much better up here in our R&D dry room, and we use that to homogeneously distribute the dry air into all of the rooms so we don't have any humidity nests. What we can also see is FFUs in here, and we actually use pretty big FFUs, so we can only have 2 or 3 of them instead of hundreds underneath the ceiling, and then we blow the air from the FFU into the textile hoses to actually distribute the air. And this means all the air is not only dry but also clean, because most dry rooms are also clean rooms.
So you are standing now inside our dry room and you can feel the dry air. And what we've done now, we created a small experiment in order to show what dry air actually means. So this experiment I will shortly explain, and you can see it later in a video also. We have a pine cone that has the behavior, it closes when it's wet and it opens when it's dry, or in hot conditions. And on the other side we have silica gel, and this silica gel has the behavior when it's wet, it has green color like here, and when it's dry in starting conditions it has the orange color. So normally you would regenerate the silica gel by putting it in an oven and bake it for 90 minutes in 100 or 150 degrees temperature. But we can actually do the same here in our dry room, and we've done that on the one hand side inside the room and also outside the room. So minus 50 dew point versus plus 5 dew point. So outside again, we can see here on our monitoring screen what the actual values are now after we've been inside our dry room. And we can see here the dew point changed from minus 56 to minus 52, 51. And this is the reason is us actually, because we produced humidity all the time And on purpose, by the way, we turned off the dew point control in order to show you this effect. And here we can very, very good explain why the approach of so-called mini environments is so important and will be the future on our point of view. Because with mini environments, we take out the humans from the process. The battery production is done automatically. No humans, no moisture in the process, almost no moisture. And then we are confident that we can reduce energy consumption of the dry room by 80%. So we hope we could explain the topic of dry air, of dew point, what equipment do we need to produce dew points, how a dry room looks like, how it feels like to be inside a dry room. I hope we could explain this to you, and I hope you liked it.
Yeah, well, as the next step, we're going upstairs to our engineering department and show you a big dry room actually on VR goggles, so you get the chance of getting inside a huge dry room yourself.
Okay, let's go.
Okay, so now we're up here. You shortly get the VR goggles to actually get into our dry room, and this is a dry room we actually built. So you can have a look around there. There's actually machinery in there. You can see that it is a little bit more cramped than in our dry room, even though it is little, the one that we had downstairs. And just have a look around and I'll explain what you can see there. So
All right.
yeah,
Looking
have a
forward.
go. So Simon, if you look around here, you see our dry room. You see up there where you're looking now, the ducting in yellow, which is actually the return air ducting, where the air from the dry room goes back to the DHU. And what you can also see up underneath the ceiling is blue textile hoses here, exactly. These we use to homogeneously distribute the dry air to the whole room, as we've seen downstairs in our small R&D room, okay? And well, you see this room is actually a little bit cramped because there's a lot of machinery in there. Well, and this is how it is in real life as well. But what you can also see is that there's persons in there, and these persons, they actually emit humidity, as we've seen downstairs as well, and they actually increase the dew point, which we don't want. So that's one reason why we want the mini environments. So actually we use this obviously to consult our customers so they can have a look inside their dry rooms before they actually have it built on site. So this actually helps everybody to make the dry room smaller if they fit all the machinery in, and then helps us to understand what's actually being built. It helps our engineering team, helps our sales team, and actually minimizes interfaces.
I think I have a picture.
Okay.
Thank you for elaborating. It was insightful, right? To see like really the 3D picture of the extent.
Okay, well, thank you, Simon, for visiting us. I hope you had a good insight in our company, what we're doing, our key innovations and competencies, and yeah, it was really good having you here. Thank you.
All right. Also, thank you, Util, for showing me around. Thank you, Jan. And yeah, looking forward to see your innovation hitting the market.